Bar charts show us the value of a variable in different conditions. Now we're going to look at histograms. This visualization is useful because it shows us the entire distribution of values within a variable. Let's look at another example. In this case, we are looking at data about the athletes who participated in the 2016 Olympic Games. We've extracted two data frames from this data: all of the medal winners in men's gymnastics and all of the medal winners in men's rowing. Here are the 5 first rows in the men's rowing data frame. You can see that the data contains different kinds of information: what kinds of medals each competitor won, and also the competitor's height and weight. Let's start by seeing what a comparison of heights would look like with a bar chart. After creating the figure and axes objects, we add to them a bar with the mean of the rowing height column. Then we add a bar with the mean of the gymnastics height column. We set the y-axis label and show the figure, which gives us a sense for the difference between the groups. But a histogram would instead show the full distribution of values within each variable. Let's see that. We start again by initializing a figure and axes. We then call the axes hist method with the entire height column of the men's rowing data frame. We repeat this with the men's gymnastics data frame. In the histogram shown, the x-axis is the values within the variable, and the height of the bars represents the number of observations within a particular bin of values. For example, there are 12 gymnasts with heights between 164 and 167 centimeters. So the highest bar in the orange histogram is 12 units high. Similarly, there are 20 rowers with heights between 188 and 192 centimeters. And the highest bar in the blue histogram is 20 units high. Because the x-axis label no longer provides information about which color represents which variable, labels are really needed in histograms. As before, we can label a variable by calling the hist method with the label keyword argument, and then calling the legend method before we call plt.show so that a legend appears in the figure. You might be wondering how Matplotlib decides how to divide the data up into the different bars. Per default, the number of bars or bins in a histogram is 10. But we can customize that. If we provide an integer number to the bins keyword argument, the histogram will have that number of bins. If we instead provide a sequence of values, these numbers will be set to be the boundaries between the bins, as shown here. There is one last thing to customize. Looking at this figure, you might wonder whether there are any rowing medalists with a height of less than 180 centimeters. This is hard to tell because the bars for the gymnastics histogram are occluding this information. The occlusion can be eliminated by changing the type of histogram that is used. Instead of the bar type that is used per default, you can specify a hist type of step, which displays the histogram as thin lines instead of solid bars, exposing that yes, there are rowers with the height of less than 180 centimeters. In the exercises to follow, you will create your own histograms.